The CICS TS feature pack for Modern Batch allows for the development of Java Batch applications in a modern and intuitive Eclipse environment, either using the CICS Explorer SDK or Rational Application Developer. In this scenario, we'll use CICS Explorer to look at one of the supplied sample applications, CatalogManagerStockUpdate, to explore the components of a Modern Batch application. Here we have our development workspace. In the Package Explorer view of the Java perspective, we have a Java project. This contains the various components of our Java Batch application. The build path must be configured on the project, so we can access the necessary jars for the application. The feature pack has two required jars, Batch Framework and PGC Runtime. The application in question requires com.ibm.kix.batch for the use of CICS supplied data streams, as well as com.ibm.kix.server and com.ibm.record for using the JCICS API. Batch applications are broken down into one or more job steps. To create a batch job step, we create a new Java class in the project implementing the batch job step interface found in the PGC runtime jar. This interface gives us a framework to build the application's business logic upon, as shown in this class. The CatalogManagerStockUpdate class contains our completed job step logic. Firstly, we define some components as they are known to the application, such as the input and output streams. We use createJobStep to set up application resources, including the batch data streams recently defined. We call destroyJobStep at the end of the job to clean up and pass a return code to the caller. We also pass some additional logging information. In the XJCL, we can pass properties to the application. Once we make these available via the setProperties method, we can use the getProperties method to return the properties to the batch job step. The business logic of the application is carried out within the processJobStep method. In this application, we read a record from the input file and the record to be updated in the output file. We pass this information to a COBOL program to perform the business logic and to update the output file with the new value. setProperties is called from the batch container to make the properties specified in the XJCL available to the batch job step. Now that we have the application's business logic, the next component to explore is the XJCL for the application. The XJCL has elements for expressing all of the information needed to define a batch job, which we'll look at in more detail soon. For organizational purposes, we've put this in a separate folder within the project. At the start, we have basic information including the application name, its job type, and its scheduling mode. This is used by the job scheduler to dispatch to an appropriate environment. Next, we define a checkpoint algorithm. These are used to determine how often CICS commits a unit of work. Then we define a results algorithm, used to determine how return codes are handled. Our example uses one job step, declared here. We point to the Java class we just created, where the application's business logic resides, and we reference the checkpoint algorithm above, which we want to use. We then define our batch data streams, an input stream and an output stream. These are Java objects which provide a layer of abstraction for the data stream processed by a batch step. This creates a well-defined interface so that the batch job step can be easily changed to use a different resource type. We have the names as used by the job step's Java class, the class for the data streams themselves, and any properties required or optional to be passed to the data stream. Finally, we declare any properties to be passed to the job step as a whole, in this case enabling debug for additional information to be logged. We now have our developed application. Please see our next video for steps on exporting the packaged application as a jar and configuring your execution environment to enable the application to run.